first cycle. Already started. Okay, nice. Nice start for that. But I'll put it below. Sadly enough, so it's going to be increased. Okay, good morning, evening, afternoon to everyone. It's my first time streaming here, so I hope it goes well. Let's see. Where's the live exactly? I can see the live. For some reason I don't see it. Wait, chat is disabled? Why is chat disabled? Hold up. Put it for kids, chat might be disabled. Let's see, does it work now? Yeah, I see a stream. Yep, chat works. If you don't hear me well, or if someone joins even, you can tell me. Okay, I fixed something. Sadly enough, my internet is not the best, so that might happen sometimes. Okay. Let's explore this app for now. I'm new to it, so home. My stuff, custom. I don't know how to go back into that thing. So I guess I'll have to look at new one every time it crashes, sadly, because my internet is not that good yet. I don't know why it's like that, but it is, so we can't really do anything, sadly enough. There we go, we're back here. That's exactly where I wanted it to be. I hope at least someone shows up. Okay. This is this. No, I can't read. Nice. Yep, okay. Now back to stream. Okay. Just does work. Good to know. Good to know. Just does not. It does work. Okay. Sadly, this might happen a lot. I'm incredibly like I don't know how to describe it. I've wanted to do it for a while by now, but I guess now it's the time. Things are gonna be a bit rough around here because it's math. Not everyone likes this, and not everyone needs help either. So like, a lot of people might just skip over or never see this ever in their life. hopefully it goes well and people will want me to do it. Now that I'm sorry if it's a bit rough to read what I've written there. It's pretty hard. Let's start by making some stuff that I won't make 20,000 times later. Okay, point. This is the x-axis and this is y-axis. This is for circular math, basically. Move here. This is a circle. On this point to this point, a line. This line is the radius. I'm not that good at my writing, at least is not that good. Funnily enough, it's really not good. I hope I could help anyone, at least one person want to help. If anyone is here, I'm in the Discord call in my server if anyone wants to join or needs help. I'm there now. Yeah, everything's fine. Yeah, you can see how I. There's a bit of practice of this app. Now I'm waiting for some people. Oh, suddenly on the back. It's fine. I wonder if people will actually even come. Let's see if the YouTube algorithm wants to help me, and if anyone needs help. For now, I'll do some. Functions. Integrals. Okay, let's see. I'm bored, so I'm looking right now for stuff to do while people join here. Because until someone sends me a question, I basically have nothing to do and I'm just waiting. So yeah. Let me search up WhatsApp whatever. I think it might download. I might have it. Yes, I do. Yes, I do. Nice. Okay, let's go to a random page. Do some integrals for fun. So weird. I think that I'm doing this for fun. X X. It's just 2e1 divided by x. 2 of these. Okay, so that won't leave me there. This is it's just like e x x correctly. So is just x times. Let's see, did anyone ask anything at all? No. Don't know what I'm gonna do, so I guess that's gonna be a I guess e dot k. It's a bit it's not the nicest function, so I'll integrate this. Let's do the di method. Divide, integrate. Not divide, what am I saying? X is actually that's oh yeah, I forgot that. I can also put it as my no, that's not helpful actually. E to the 1 divided by x. Okay, now it's gonna be di plus 1 wait, I forgot to put the basis. X is actually nice. Okay, so let's do a verification. That we have e plus yes, indeed correct. So integrate this is what? That's 1, that's minus, that's plus 0. Wait, did I forget how to do it? Am I stupid now? Is this and this? Is this? Oh my gosh. And this and this. Okay, yeah, I remember now. Yeah, don't remember, but yeah, indeed doing it this way. So I need to integrate this. So it's a very big endless loop, it seems. Because it's gonna be divided by half. It's gonna be it's basically gonna be like 1 plus half plus fourth plus. So I'll do it my way, which is gonna be it means basically the integral will be 1 2x like this. Which is fair enough based on this, just 2 times this. 2x, okay. The integral of this is and then this, and the integral of this is going to be half the integral of this. So yeah, it's basically going to be around 2. Now let's do this. 2e like this plus just 4e this, so indeed incorrect. I believe it's going to be just the fact that I've personal belief it's going to be not going to be a 2x moving the 2 is times actually it's not. That's fun. Maybe 1.5. No, 1. So it's going to be this divided by this part by x squared stew. No, it's going to be divided by x. Which which the integral of that this is just I think I found an endless loop integral. That's fun. Fun to find, not fun to do. So basically endless for me. Let's see. Anyone here? Doesn't show me any messages or in the chat, so let me refresh. Maybe just maybe. No one's here yet. That's fine. Let's go here back. Find another integrable thing. Something that looks fun, not just annoying. Integral. This looks fun. Okay, we got the integral of. Oh, the board isn't endless, but it is more than I thought it is. Or maybe it is endless, I don't know. This is equal to square plus x plus 1 e minus x. So, integral is equal to plus x e minus x integral dx plus e minus x in the integral dx. Let's do it part by parts. Integration by parts here. Let's do di e minus 1 x squared. So I got x squared. It's plus, that's minus. Which is 2x e to the x of 2, that's plus 2 and this is going to be with minus e to the x again, so that is 2 here, my bad, I meant a 0 here and then minus, we got and we got this which is the multiplication of these to these, the minus sign with another without the other minus sign because there is no minus here, this minus up, and this pluses apply only to these line, so it's minus 2x minus e to the power of minus x minus times plus is minus 2 e minus to the power of minus x. So got one part finished. Now the next one, x e minus x di. This is going to be 1, this is going to be minus e to the x, plus that's minus, and next one is 0 times e minus x. So we start with this 2 and these 2, which is minus e to the minus x times x minus e minus x. That's the second part. The third part is easy, it's just e minus x. The integral is just this. So all we have left to do is combine minus x to, first everything has e to the minus x in it, so I can do something very, very simple. Put e to the power of minus x here, and inside put everything else. We got minus 1, minus 2, minus 1. So it's minus 4 if you combine all of the factors I just stated. Then you got minus x times 2, and you got 1 times this and 1 times this. So you got in total minus 3x plus c, of course. But maybe, let's see if there is a solution to this. Minus 3, 4. Okay, so I'll put the minus outside so it's easier. Minus this x squared plus 3x plus 4 plus c. Now we got 3 equal to a plus b. A times b equals to 4. So b is equal to 4 divided by a. So we got 4 divided by a plus a equal to 3. X squared minus 3a plus 4. This makes us get the the same thing, which doesn't help. So let me just do it in the harder but nicer way. Let's see if there is a solution to this. A real solution. There's always a solution, but let's see if there's a real one. This is going to be the b. B is 3. C is this c, not this. Not be confused. I'll change this from c to plus k, let's say. Okay, b is 3, c is 4, and a is 1. So we got our reminder, minus b plus minus root of b squared minus 4ac divided by 2a is the solutions for this equation. So we got the we got an a, b, and c. So I'll just put them in, basically. Minus 3 plus minus 9 minus 16 divided by 2, like I thought. 9 minus 16 is, I believe, minus 7. Is minus 7 minus 9? Yeah. Minus 7 is equal to this is complex number where, as you know, minus 7 is equal to minus 1 times 7, so we'll just put root of 7 out. Here's a root of minus 1, which is square root of 7 times I, because square root of minus 1 is I. That's a definition. So there are no better ways to put this in, but just letting you know, there is a solution in the complex field, which is more complex, as the name implies, than normal solution. But I'll just continue it with the complex solution for fun. So we got x1 is equal to minus 3 divided by 2 plus square root of 7 divided by 2i. x2 is equal to minus 3 times 2 minus square root of 7 divided by 2, the 3 over 2, 7 over 2, square root of 7 over 2i. Those are the solutions for if this is equals to 0. But as I said, there are no real solutions, so we are not doing it. We don't need to do the thing, like we don't need to do the we don't need to do stuff like x minus 3, x plus 2, because there are no real solutions. It will look like, with the solution I found, minus will be this plus this and x plus 3 this minus root of 7 divided by 2i, like this. So because it's way harder to work with that, we are not doing it. And that is about all of this, and that is about everything in that integral. Nice. So I'm done with this thing. As you can see, I'm removing everything because we are finished with this one. Now we move on to the next integral, which is gonna be as stated. I'm still waiting for a question. For now, I'm just looking up integrals and doing them. And now, after an integral, let's do a complex field. Complex field. For those who do not know what a complex field is, it's a circle. It's basically the same as a normal circle. Aw, that's close for actually doing something looks nice. Yeah, I'll do this for now. Okay. This is a part of the real world, which is the real numbers like 1, 2, 3, and such on. And this is the complex, the imaginary, which are square root of minus 1, which is I, 2 divided by 3i, anything with I, so on. This is still the real part, just in minuses. Minus 1, minus 2, minus 3, and so on. This the same applies here. This is minus I, minus 3 divided, I'm not sure how you say that, 3 over 2i, I think, and so on. Now, this is called the Gaussian field, and it has every number basically. and the radius is typically 1, but it can vary. It doesn't have to be 1. It depends on like the number here and the number of the eye. Like if the point is here and that's 1, and 1.0 like this, it means it is radius 1, because the difference from here to the middle of the circle, this length is 1, so the radius is 1. But it can be anything, it doesn't need to be 1. For the basic stuff, it's 1. It starts with being 1, then it can change and basically do anything it wants. It doesn't have any rule. But here, okay, so how do you remove a circle? How do you remove this? Oh. I guess this is how. I select everything, then so we got W, which is a complex number. Oh yeah, forgot to define a complex number. For those who do not know, a complex number is basically it's a combined real numbers and imaginary numbers. So a complex number typically put with the Z is, for example, 1 plus I, or 2 plus 1I, or anything that has both a real number plus an imaginary number. Reminder, imaginary numbers. Imaginary numbers are ones that have I with them. And real numbers are normal numbers, any number like 1, 2, 3, 4, and anything. And it is represented usually as x plus yi. So same goes with w here. It's the same as z. W is x plus yi. We got the equation w plus I times squared plus this plus I and this. Okay, before I continue with this, I'll need to explain more stuff. This is a very close number to this. The difference is that it has, of course, as you see, the line on top, and that means if w is x if w is equal to x plus yi, w with the line on top is equal to x minus yi. If w is equal to x minus yi, it's the same rule basically. W, the line on top, is equals to x plus yi. All it does, it changes the plus to a minus and minus to a plus of the imaginary part. The real part, like for example, let's do w equals 3 plus 5i. The w with the line on top is 3 minus 5i. As you see, the only part that is getting changed is the part that has the imaginary number, and the only difference is the symbol. Plus becomes a minus, minus becomes a plus. The real part stays the same. So further, we will explain this. Okay. As people might know by now, usually this of a number, let's say -1, is 1. This implies absolute value, but in the complex field, it does not mean an absolute value. It means the distance from the middle of like the entire xy axis, this point, the distance from this point, which is 0, 0. So it's basically just x plus it's x minus 0 squared plus y minus 0 squared. And do remember, the I does not go into this. If the I went into this, it will be the solution to this firstly is x squared plus y squared. If the I went into this, it would be something else. It will be x squared plus y squared times I squared, which is x squared minus y squared. As you see, there is a big difference if you put the I and if you don't put the I. So let's go. So let's put a number value, random number. W is 3 plus 4i. As I said before, the W with the line on top is 3 minus 4i. Now, I can also put them on the graph I showed earlier. Make a straight line and another straight line. That's x, that's y. This is the real part, which is 3. We will, in addition, you put them, to turn this into a point, it's just 3 plus, and this, I forgot how you call this, a comma, I think, 3 comma 4, and this, because it has the minus, it's 3 comma minus 4. That's it, basically. So we go here, let's say this is 3 comma 4, and this is 3 comma minus 4. This is a distance and this is a distance, which is what we're about to calculate. As you see here, let's start with W. W is going to be this of 3 squared plus 4 squared. As you see here, I made a mistake. It's this 3 squared plus 4 squared, which is 9 plus 16, which is 25, which is 25, of course, square root of 25, not 25, which is 5. The solution to this is 5, because 5 times 5 is 25. So, let's try it with the line above the W. The distance is 3 squared plus 4 squared, of course, root of, second root of, basically, is equal to root of, second root of 9 plus 16, which is the second root of 25, which is 5. So, as you can see, both got me 5, because simple rule, the distance from W to the W with a line on top is equal. if you want me to prove it with numbers rather than just with like integers rather than just numbers, it's very, very easy. It's root of a squared plus b squared, and this is just the same, a squared plus b squared. You can also prove it from this. As I explained earlier, you got this, which is a field. As I said, as I presented the points, this, let's call this a minus b, and this a comma b. This is this, this is this. Firstly, you can see they are on the line x equals a, and this is x equals a is this. I forgot how you say it. I'm sorry, guys. X equals 0, which is the y-axis. Which means it's this to the x-axis. X-axis. Because of it, you know this is 90 degrees. Now this point is a comma 0 because it's on the line x equals a. This point, as I said, is 0, 0. The distance between these two is b. The distance between these two is b. This is a. Because a and 0. So if you go by Pythagorean theorem, you can see that this, I'll call it k, and this will be t. So t squared is equals to a squared plus b squared. So t is equals to a squared plus b squared under the square root. So, and as you might know, there is plus minus, but because it's distance, the plus minus does not apply. So let's do the other one. K squared is equals to a squared plus b squared. So k is equals to square root of a squared plus b squared. Hence, proven by a third way. So, now, after we finish this, let's start doing something. Let's remove everything from here. We'll go here. Okay, we got. Do we have any new viewers or any questions? No. I might end the stream soon because no one is even entering it. Okay, so we go here to do the thing. Okay, so if this is square root of x squared plus y squared, so what is this? The distance, by the way, you call this of w, the complex number, you call this distance. That's how you calculate the distance from 0, 0. So what is this equal to? It's pretty simple. As you might expect, it's just this. The same thing as here, with the square root and everything, just squared. And what is square root of a squared? It's just a. Based on that simple thing, you know that x squared plus y squared is equals. It's equal to this. And of course, the same goes for if instead of one, and the same goes for square, of course, which is also equal to the w with the line on top, distance squared. As you see, we are progressing. So far, so simple. Now, after we've done this, we got a lot more stuff in complex world. For example, what happens if I do distance of w plus 1? This, the distance of this. As you know, w is x plus yi, where x is real. By the way, that's how you mark x is real, and y is also real. Real, it's just saying that it is, you do this, then put a r with double stuff on it. Don't ask me why double, it is how it is. Now, so after we know this, what do we need to do, you might ask? We just put them in. X plus yi plus 1, of which distance. Let's put the complex numbers and the real numbers into a different place. This is a complex because real, which is this, times imaginary, not complex number, imaginary number, is here. So let's put them into their own closed brackets. X plus 1 plus yi distance. As you might see, it's fine, it's really fine if you don't, because it's a new thing for you. It's just the square root of x plus 1 squared plus y squared. That's it. Same goes for if we do it the opposite way. Distance of x plus y plus 1i. It's just the same as it here, just instead of adding 1, I added I instead of 1. I instead of this 1. So what it makes is the same thing, but a bit different. As you see, it's y plus 1 times I. So it makes x squared plus y plus 1 in brackets squared, of which it's the square root of this. So this is distance. This is how distance work in the complex field, and how complex field really works and stuff like that. So let's do a equation. For example, you got x plus yi, and you know that it's equals to 7 plus 6i. How do you solve this, you might ask? You see how some numbers are real and some are imaginary because they have the I to them. So, in order to solve this, it's very, very simple. All you need to do is put the real numbers combined with each, like make the sides equal to each other. If this is real, x is real, and 7 is real, you put x equals 7 because x is here and so is that. So it's x equals 7. If y is imaginary and 6 is imaginary, you put y is equals to 6. And then as proof to see, I can just plug them in. As you see, 7 plus 6i is indeed 7 plus 6i. Now, let's prove it further. X minus 4, x plus 1, plus y squared is equal to, let's put x plus 5i. We know that this is of course with I to it. We know that y squared is equal to 5, right? You see here? From here we know y is either square root of 5 or minus square root of 5. Now here, let's put this. It's x minus 4. Let's combine it with the x here, because the x here is not imaginary. It doesn't have I to it. So it's x minus 4 times x plus 1 equal to x. I'll just open this up real quickly. Minus 4x plus x minus 4. It's just the opening. You multiply x by this, then just multiplying each number of a certain bracket, like x by x and x by 1. Then the same with here. Minus 4 times x minus 4 times 1. And now we start from minus 4. Yes. So we got x squared minus 4x minus 4 plus x. As you see here, the x, I just put a minus x. So minus x is equal to 0, because x minus x is 0. So put those out. So we got x minus 2. No, this has no real solutions, because if we plug it in the formula, x1 okay, so if you can hear me, that's really good. I'm fixing stuff now, because as you see okay, so let's continue our work. So it's literally x1 comma 2 is equal to 4 plus minus square root of 32 divided by 2. Not yeah, I'm pretty sure it's divided. Yeah. So 2, what you get from here is 2 plus minus root of 2 times root of 16, which is just 4. So I'll write times 4 divided by 2, which is 2 plus minus 2 root of 2, which makes us get 2 plus 2 square root of 2 and 2 minus 2 times square root of 2, which are the solutions for x. So in the end, we get 4 different points of which work when x is equals to 2 plus 2 square root of 2 and y is either plus or minus square root of 5. That gives us 2 points when it's minus 5 and when it's plus 5. And here another one, 2 minus 2 times square root of 2 when y is equals to plus minus square root of 5, as these are proven. These have been proven by me a bit before, if you remember. Here, this part gets us this. So in conclusion, we got 4 points. 2 from here. 1 is when this is itself, which it will always be itself because there's not plus minus. we get this x, I'll mark them as x1 and x2, and I'll mark y1 as minus 5y and minus square root of 5, my bad. And y2 is square root of 5. So in conclusion, we got 4 points, which are x1 comma y1, x1 comma y2, x2 comma y1, x2 comma y2, which are all our 4 solutions. Now, it's not always like this. There are a lot of different problems here, and every problem has its own solution, and every problem is very different from each other. So the answer is always different. It's not going to be the exact answer for every single question. As you see, this is the solution for here. But what was the solution for the thing I've shown you before? Let's see. 7 and 6. Thank God I did not flip it, or else I would be mad at myself. Okay, so as you see, this is most of the complex field explained very shortly. If you want more of the complex field, you are free to say so, but currently there is no one watching, so I've basically done an hour of explaining math to myself, which is fun, neat. Okay, so as in all these solutions I've shown you, we got 2 more things which I will not show today. W, as you know, is x plus yi. But there is another thing which you can represent it as r cos of x plus I sine of x. And also w squared is on this term, w to the power of n is equals to r times n. Oh, and before I move on, this is this part, we just write it as r times kiss or cis, whatever you want to say, because it's cosinus plus I sine x. So, how, as I was saying before, w to the power of n is equals to r to the power of n times kiss the power of kiss x, of course, to the power of n, which is just r to the power of n times cis to the power of n, not to the power of, my bad, cis of n times x. This is it for today. Anyone that watched this stream, if you are watching, and even if you aren't, and even if you were watching it after the stream ended, I hope you have a great day, a good day, or anything really. I hope all good for you, and I'll see you soon, I guess. So goodbye for now, and hopefully everything will go well and y'all can join someday, because all I want to do is help people with math and show you how math can be fun and nice, and it's just everyone, not everyone, but a lot of people fear math. You shouldn't fear math. Math is great. It gives you a lot of things. All you need is to understand it. So, any questions can be asked if you are watching the stream later. You can also join the Discord channel, which I put in the description, and go ahead and ask me any question you need over there, and I'll answer any question you want in the Discord channel. So I hope you have a great day, as I said, and